This is Joseph Louis Lagrange. He was born in 1736 in Turin in the Kingdom of Sardinia, also known as modern Italy, under the name of Giuseppe Luigi Lagrangia, which he then changed when he was naturalized French to his name now. He then died in 1813 in France, or the First French Empire at the time, in Paris. He helped make significant contributions in the field of analysis, mostly dealing with limits in number theory, and both classical, which is the orbit of an object around Earth, and celestial mechanics. One of his most notable scientific contributions is one in the calculus of variations, which he was one of the creators of. The calculus of variations is basically, it uses the variations of functions to then calculate the maximum and minimums of those functions, and then map out a set of those functions to the real numbers. To do this, he derived one of his own formulas paired with Euler, the Euler-Lagrange equations for the extrema of functions, and he extended the method to include possible constraints or limits, arriving at the method of Lagrange multipliers. In 1790, he also played a major role in the development of the metric system, leading us to actually use the metric system in our everyday life by using kilogram units with a decimal, kilogram and meter units with a decimal subdivision. In the 18th century, lots of things were happening in the field of astronomy. First of all, it was super important since it was used for navigation, but also Galileo and Newton, who had both been a key in the advancement of astrology in the world at the time, had done previous theories, such as Newton's theory in predicting the movement of the planets and comets in our solar system, due to him having created the modern telescope in the early 18th century. In Berlin, he worked lots on astronomy, attempting to solve the three-body problem, which is taking the initial position and velocity of three point masses and solving the subsequent motions according to Newton's law. The solutions that he found were later seen to explain that are now known as the Lagrangian points. He also proved the theorem that stated by Batchett that every positive integer is the sum of four squares. For example, if p would be equal to 4, then 1 squared plus 1 squared plus 1 squared plus 1 squared would also be equal to 4. And that works for every number ever. Moving on to his work in France, as I said, he worked on differential calculus and calculus variations earlier. He also worked on number theory and celestial mechanics, where in number theory, he also gave a method of approximating the real roots of any equation by means of continued fractions, and also worked in celestial mechanics in the theory of planetary motions that had formed from the subject of some of the most remarkable Lagrange-Berland papers. He was also awarded several prizes, such as the French prize in 1764 of the French Academy of Sciences for his memoir on the liberation of the moon, which is the wavering of the moon perceived by Earth's bound observers and caused by changes in their perspective. Some modern uses of Lagrange's equations come in robotics, where they are used to determine the power output of any necessary robot by deriving certain components of the robots, such as L and theta.